Good afternoon, everybody. I'm Brian Norcross, and this is Fox Weather's Hurricane HQ&A, our kind of regular talk session during hurricane season to talk about everything we can think of to talk about related to hurricanes. And today we have a very special guest, my old friend, Dr. Phil Klotzbach, who is the lead researcher on the Colorado State seasonal forecasting team. And we're going to talk about seasonal forecasts, not just the fact that they're all forecasting a relatively quiet hurricane season, but kind of what's under the hood. And maybe we'll even look at hurricane season 2027 and see what this season can tell us about that, which is an interesting conversation. Plus, we have some new updates that came out from Google today, talking about their model and how it's working and how it's been working. And it's interesting always to talk about these new AI models. And also in New York is Jordan Overton at Fox Weather headquarters, and he'll be taking your questions and presenting them to us. So if you have any questions for me or for Phil, by all means, send them in on whatever platform you're watching, whether you're on YouTube or Facebook or X or LinkedIn or whatever it is, TikTok. We'll take your questions here and do the best we can to give you some answers. But before we do that, let's go over kind of where we stand. And first of all, today, NOAA scientists came out with their updated forecast. Phil and his team at CSU put out theirs yesterday. So here's what they show. And you see that, first of all, the CSU forecast yesterday settled on 9 named storms, 4 hurricanes, 1 Category 3 or above a hurricane, which was the same forecast they'd made in June. And we'll talk with Phil about this in a moment. But what I've been saying, Phil, is that your forecast didn't really change. It's just the certainty of this strong El Nino changed over time. And that's why the numbers went down, just because of certainty, not because we didn't know or didn't suspect strongly that an El Nino was coming along. And when the named storm number was 13, that was still a low number compared to what we've seen in the last few years. All right, the NOAA numbers in May, they were 8 to 14. They give us a range and not we could always just choose the middle number, I guess. But anyway, they give us the range. And now they've lowered it a little bit. Same reason. The certainty of a strong El Nino. El Nino sort of squash hurricane activity, make it much more difficult for strong storms to form and storms to form in general. So they've lowered their numbers to 7 to 13, 2 to 6 hurricanes, and 0 to 2 Category 3 and above. So we'll see exactly how that works out. But these numbers all include 2 that we've had already. So the whole rest of the hurricane season, somewhere in that 7, 8, 9, 7, whatever, some fairly small number compared to what we've been used to. Range is what is indeed forecast. So all this is based on this El Nino and the way we measure El Nino. It affects the weather pattern all over the world, but the way we measure it is we measure the temperature in this box here along the equator south of Hawaii. And the warmer that gets, the stronger the El Nino. And it is getting like super warm in the middle of a big marine heat wave out here. I mean, look at this huge area of above normal. So where it's red, it's above normal. This is a tremendous amount of heat. First of all, to power tropical systems, but also putting a lot of heat in the atmosphere. So we're going to get more storms in the Pacific because of that. They have more energy. And here is the updated forecast of how strong the El Nino is going to be, according to the European Center, the people that put out the Euro model that you all know about. And here's the line for a super El Nino. Now, it's pretty darn rare to have a super El Nino, or it's actually called very strong El Nino, but everybody calls it super El Nino. And look at the forecast up here. I mean, there's a 100% chance of it being above a super El Nino, or above the 2-degree line, 2 degrees Celsius above normal. And look at this, is up in the 3.5 range here in terms of an average. So this is spectacularly warm, which will have a dramatic effect on the weather in many places in the world, including drought in some cases and the extra heat. But for what we're talking about, the real suppressing effect on tropical activity in the Atlantic. And how does it do that? It does that because it creates these very strong upper level winds. Here you see them forecast here over the next few days over the Caribbean. You see that's all in the strong to very strong part of our scale up here. And notice this band goes out all the way across the Atlantic. It varies a little bit. Sometimes it's down here, but it tends to be for sure in the Caribbean, which can produce and normally does produce a drought in the Caribbean, which is not good for those folks on those islands there. They don't want a hurricane, but they don't want a drought. Either. And then we have the dust, and this is the dust right now. So there's nothing tropical that's going to go on out in there. That's a lot of dust. And we go ahead a few days there. You see it spreading over toward the Caribbean, makes the skies milky. And some of that might even get into Florida early next week, which would be normal for this time of year. Dust is normal this time of year, and normally it fades out as we go through August. And then we have the water temperatures out in the Atlantic, slightly warmer than normal in this box here. But the thing is, if the upper level winds are so hostile and there's a lot of dust, even though the water might even be warm enough to support a tropical system, everything else is not good for it. I mean, this is the bottom line here is it's not going to add energy to tropical systems this year. Then with all the other negative factors, that's why the forecasts are lower. Now in the Pacific, Hurricane Center has two areas to watch. This one over here, it doesn't look like it would be anything, stay offshore. This one here is another question. And so let's just look what the models say. This is for the next week, that something could develop there and a low chance over the next week. This is more 8, 9, 10 days from now. And we can look at the satellite and we say we don't see much of anything there, maybe just a little disturbance. But when we look at the models, you see they don't have much, just kind of random L's, little clusters of L's. And these are only two models, notice, that show it, the European model here and the European AIFS model, which is the AI model run by the Europeans. So they run both separately. And you see just nothing definitive, little clusters, and nothing from Google, but they usually don't pick it up early. Now let's go forward in time and watch as we go forward here, and you start seeing, oh, there's a blue, there's a few more blues. So as we go forward in time here, this is into next week, you notice now we're getting two clusters, one in here and one over here, and that represents those two possible development areas that the National Hurricane Center was highlighting. And then let's go forward in time. So now we're all the way to next Wednesday. Now let's go forward a little more toward the end of next week. And now you see a cluster that's kind of heading toward Hawaii. Now, obviously, if it's down here, that doesn't affect Hawaii significantly. If it's up here, it's in the cold water. So we'll see if first of all, if this happens, because this is well out into the future. And secondly, if what exactly the threat to Hawaii might be, if there is a threat. But just the bottom line is, in Hawaii, be aware that something may be coming toward the end of next week or the following weekend or into the following week. Anyway, way in the future, but it is kind of amazing that we can do that kind of thing these days, and the models support it. All right, so let's bring in Dr. Phil Klotzbach with us. So Phil, first of all, the European forecast there is as aggressive as any forecast I've ever seen. I mean, you look at these things, I have looked at them for more years and looked at them more often than I do, but have we ever seen a forecast, with an average of European, first of all, 100% above 2 degrees Celsius in the super El Nino range, and the average at 3.5 degrees in the El Nino box, the 3.4 box?
Yeah, I mean, this is certainly an extremely aggressive forecast. If you look at kind of how it's been tracking, if you look back at say like April, especially May, it's actually tracking a little bit even on the cool side of their ensemble, so towards the low end. The last 2 months it's been a little too warm. So we'll kind of see how that plays out. But even if you take the lowest ensemble member that it has, that's still one heck of a strong El Nino. When you look at water temperatures right now, I mean, it is extremely warm. If you go towards like the Eastern Pacific, you have water temperatures that are running 3 degrees Celsius warmer than normal. And, when you're talking like 4.5 to 5 degrees Fahrenheit in the tropics, that's a huge deal temperature wise. So, this is certainly, it remains to be seen if this is going to be the strongest El Nino, and it probably will depend on like a lot of things, like how we keep score, like what exactly are you looking at? But it's certainly going to be rivaling some of the strongest. If you look at water temperatures near the Galapagos Islands right now, they're in the 26.5, 27 degrees Celsius range. That's just insanely warm for that region. So likely we are going to see very significant impacts. Obviously, we've already seen very significant impacts in vertical wind shear in the Atlantic. So the Caribbean shear the last month has been basically pretty much neck and neck, effectively tied with 2015 for the strongest on record going back to the late 1970s. So we're already seeing really the strong El Nino impacts. It's not always when El Nino comes in. Sometimes it takes a little while to kind of see the El Nino lock in, but certainly I would say even about 6 weeks ago, you really saw it's much stronger thunderstorm activity, deep convection near the date line, and really seeing everything lock in. And what we've seen in the Pacific Ocean as well is very classic El Nino signal. A lot of storms forming in the eastern North Pacific. We're starting to see some more powerful storms forming there. In the western North Pacific, you're seeing kind of a shift in tracks more towards the south and east. That's a very classic El Nino signal. It tends to shift where that monsoon trough is, or an area of like convergent winds where these storms tend to form in the western North Pacific. It shifts it south and eastward. Storms like Typhoon Dolphin, which probably will win the name for the best storm name of the year. That's a powerful hurricane likely headed towards eastern China. It's not necessarily going to have the world's strongest winds associated with it, but it's enormous. I mean, if
It's
you
a
look at
huge storm, yeah.
That thing is huge. So it's going to be a big storm surge problem for eastern China in a couple of days. So, really what we're seeing right now is a very classic El Nino pattern. And one thing we emphasize, obviously I focus a lot on the Atlantic. While El Nino knocks down your Atlantic storms, and strong El Ninos really tend to knock down your Atlantic storms, your Pacific storms tend to go up quite a bit. Not as much in frequency, but certainly in terms of intensity. And overall, since the Pacific Ocean is a much larger ocean, a longer hurricane season, typhoon season there, typically your busiest northern hemisphere seasons are when you have these robust El Ninos, because the Pacific, I always say, kind of drives the bus, so to speak, for say your category 4 or 5 strength storms, as well as if you get into some of these geeky metrics like accumulated cyclone energy, where you're looking at storm intensity and duration. A storm, for example, like Dolphin has generated a tremendous amount of ACE. Right now it's generated about 50 ACE units by itself, which, to put that in perspective, is what we're forecasting for the entire Atlantic season this year.
Right. Well, that's also because the Pacific is so big. You get these long track storms. So like Dolphin started way back near the international date line. And by the way, Dolphin, it's called Dolphin. We're used to the Pacific storms having kind of a Asian, some other strange name that's hard to pronounce sometimes. But the reason it's Dolphin is because Hong Kong named it, and the Hong Kong names tend to be half English and half Chinese. So this happens to be one of the English names that came out of Hong Kong. They use names from all of the kind of countries and cultures and whatnot in the Pacific, in the Western Pacific, is how that works out there. But that's why we get these giant storms in the Pacific, Western Pacific, that we don't get in the Atlantic in general, because you don't have long lead times. In fact, I guess, when was the last time we had a storm that was, has there been one since Irma that was, kind of a long track storm that went through multiple eye wall replacement cycles and got big and big and big and big, kind of like the 1926 Great Miami Storm?
I think really the two biggest ones, classic ones for in recent memory, be Hurricane Ivan in 2004, right, and then Hurricane Irma in 2017. These monster storms that form right off of Africa, get a big ridge over the top, so they go straight west. They basically soak up all this energy, take it in, and just go through these and just monster storms. I mean, if you look last year, I think last year to me is a really fascinating season, because when you look at the season, how it verified, officially it verified as an above normal season, because NOAA puts a heavy emphasis on ACE. And that's how they verify seasons, is by ACE. And last year was a season where, we had a below normal number of hurricanes, but the storms that we had were very, very powerful. So we had 4, it was a year with low frequency but high intensity. And obviously, last year to me is one prime example. I mean, obviously, you look at the last storm of the year. Up until Melissa, we had nothing in the Caribbean, zero.
Right.
And then we have Category 5 and one of the strongest hurricanes on record. So, it just goes to show you that, certainly for this year, obviously given how high the shear looks to be, it seems highly unlikely we'll see anything significant come out of the Caribbean. That's usually the area actually our seasonal forecasts have the highest levels of skill for, is the Caribbean. And obviously, given how strong this year has been and is likely to continue to be, it's extremely impressive. If you look at the next 4 weeks of shear forecast, it's like a bright blob of red across the entire Atlantic, everywhere from right from the Central American coast all the way across to Africa. So it does look like, getting anything out of the deep tropics this year is anything significant is probably going to be highly unlikely. Well, you have to look more towards the subtropics where the environment normally is more marginal, but you might get some pockets where the shear is lower. So you might get something kind of popping out of there.
Yeah. So I've been saying east of the Bahamas to the Gulf, that's the band where things normally develop. And if you go back and look at El Nino years, as a matter of fact, with the exception of Betsy, and Betsy formed in, plus or minus around Puerto Rico. I mean, they track it before that, but still it formed kind of west and north, right? And then there were all kinds of shenanigans of track and stopping and looping and carrying on. And Betsy was a horrible storm in South Florida, and then especially in New Orleans, and in an El Nino year. So, it fit the mold in that it formed generally in the western and north part, not down in the Caribbean and across the deep tropics to Africa. So this slow kind of season, Phil, does this work with your schemes for forecasting? I know you when you make your forecast, you look at a lot of different ways to analyze and compare and deduce how busy a season is going to be. Do your schemes work in this kind of extreme situation where the El Nino is this strong and the water temperatures are tepid? I mean, they're about average.
Yeah, I mean, most of our model schemes in general we're going for a pretty low season this year. We actually did redevelop so we have a statistical model which is built on just historical data. And then we use what we call these hybrid or statistical dynamical models, where a dynamical model is like the European Center. So we look at what they're forecasting, and then we'll develop basically a model off of that. So say the European Center is forecasting, warm waters, low shear. Okay, how does that typically relate to a season? This year for August forecast, we actually redeveloped the models because when I was using just a simple linear regression, we we're actually getting negative ACE values. So we had to switch to a logarithmic linear regression to make sure that we were only getting positive values, because you cannot have negative hurricane activity. So that just goes to show you how kind of anemic the models are. Just the amount. What we did with our statistical dynamical models this year was you just basically forecast the vertical wind shear in the Western Atlantic, which is where those models typically have the highest skill. And they're forecasting extremely high shear. So when you kind of regress that against historical ACE, this one would come out very, very low. So most of the models, even with a logarithmic linear approach, we're still coming with an ACE of like 40 to 50, which is very, very low. If you think about hurricane seasons in the Atlantic, it's been busy. So since 2015, which was our last powerful El Nino, 2016 to 2025, those 10 years, 9 out of those 10 were either classified as above normal or extremely active based on NOAA's definition. The only one that was not was 2022, which was considered a normal season. But of course, that 2022 hurricane season had nothing in August. And then obviously hell broke loose in September, and obviously the end of September with Hurricane Ian. So, it goes, the last 10 years have generally been very busy. So kind of having a year like this where, it looks like it's going to be quite quiet. It's just been a while since we've had one of those years. So it kind of, 2015 feels like a long time ago to me. It's been a while, so it is unusual, but we've had people say like, oh, why do you always forecast a busy season? It's like, well, the last 10 years has been busy. So we're forecasting a lot because there's been a lot. But this year, the signal for this El Nino, the European Center has always been extremely aggressive, but it has had some notorious high biases during the February, March, April timeframe, which is one of the reasons why when our original forecast came out, we said, yeah, it looks quiet. We'll probably get El Nino, but we weren't like super buying the extreme warmth that it was already forecasting. Because if you look
Well, there's the
historically,
spring predictability barrier too. So you have to
there is
kind of
that.
modify your expectations based on springtime El Nino forecast, right?
That's correct. So as Brian mentioned, we have the springtime predictability barrier, which is basically during the northern hemisphere spring. These models that forecast El Nino, La Nina tend to have lower levels of skill. Basically, just like the winds tend to be a little bit weaker, and small changes in the atmosphere can make big differences in the ocean. But we really, about late March, right after we had settled on stuff, you started to see really powerful, what we call westerly wind bursts at low levels in the tropical Pacific. So basically, very strong winds out of the west that basically started transporting that extreme warmth from the western Pacific farther eastward. And so basically, why we have El Nino in the first place is, it's always hot by Indonesia, and that heat kind of builds up, and we have basically what we call like a discharge recharge mechanism where it gets hot and we need to discharge that heat. Now, El Nino is a really efficient way of doing that. So it takes all that heat energy from the western tropical Pacific and displaces it eastward towards the eastern tropical Pacific. And when it does that, it shifts where the thunderstorms form in the Pacific Ocean from near Indonesia, closer to the international date line. And that's how it impacts the shear. As Bill Gray would say, it's that in, up, and out circulation in thunderstorms. Brian, I'm sure you heard him talk about this many times.
Yes.
And that in, up, and out circulation, the upper level outflow from those thunderstorms in the central Pacific really ramps up the shear in the Caribbean across the Atlantic. And that's typically what really knocks down your storms in an El Nino year. Now, since we have plenty of time, I'll also bring back 2023 was a fascinating case.
Right.
So
I was
this
going to
year,
ask you about that one.
yeah. So this year, 2026, pretty straightforward, right? Like we have a really strong El Nino. The Atlantic's a little warmer than normal, but the Pacific really should drive the bus, so to speak, this year. 2023, we had what looked like was going to be a powerful El Nino, not quite up to this level, but quite powerful. But at the same time, we had a record warm Atlantic. And so this was kind of a big conundrum. We have kind of these two titanic forces where if you have the strong El Nino and no warm Atlantic, quiet season, super warm Atlantic, no El Nino, big season. But because we had these two things kind of pulling against each other. And I think this is really an example where these dynamical models really help us. So those dynamical models that like the European Center, the UK Met Office, were all forecasting strong El Nino, record warm Atlantic. And not only that, they also forecast vertical wind shear. And they said, strong El Nino, record warm Atlantic, low levels of vertical wind shear. So we came out with a forecast that said we're going to have an above normal season, despite the strong El Nino, which felt like it was going against everything Bill Gray had ever taught me. But you kind of figured these dynamical models, if they get the water temperatures right, they should be able to kind of tell you what kind of the broad tropical circulation is going to be. And they did a great job that year. So I think that's an example of a case where had we had that same situation 10 or 15 years earlier, we probably would have had a fairly significant bust, because we would have said, oh, the strong El Nino will dominate. But because of that, that's where these dynamical models, I think, really play a nice role. So a statistical model is great as long as you don't veer too far out of what we've seen. Whereas if you start to kind of go out into, terra incognita where we haven't really seen this, that's where the dynamical models come in handy. I think that's honestly a case where the AI models are challenged as well. AI models tend to be like statistical models in that, well, effectively they are statistical models, but they tend to struggle sometimes when you get these big outlier events. They don't necessarily handle those as well. So when we run AI model internally for our seasonal forecasts as well. And what you kind of will see with these is that they do fine as long as you don't veer too far out of like what they've been trained on, which is historical data. If you get really far out into like, crazy other climate worlds, then they will sometimes struggle just because it's so far out of their training data set.
Yeah. So I wanted to talk to you about the Google model, which was so successful last year, but let me disclaim that I've had a little role as a trusted tester and consultant with Google, but I have nothing to do with developing the model. That's the super smart scientists at Google DeepMind that did that. So Google DeepMind, in fact, they just came out with their paper, their scientific paper today in Nature, kind of a scientific journal, and about their 1,000-member ensemble. And the idea of the 1,000-member ensemble, and what all that means is that they run the model 1,000 times, and they put little different assumptions within each one of those 1,000 members. So it's a little different than the way other models run, where they change the initial conditions. All of the initial conditions are the same, but the weights and so forth in the model are different on the various ensemble members. Anyway, they come out with a spread, and the idea of the 1,000 was to capture the outliers. It was to be able to get the 2%, 5% extreme cases. We're kind of in our infancy here with AI models, right? But don't you think in terms of your use of AI models to predict the season ahead, that this idea of a lot of ensemble members is going to be a step forward when they're the only ones doing that at the current time, because it takes a lot of horsepower to get that to happen, I guess. Anyway, what do you think about the Google model's performance last year and how that might apply to what you do?
Yeah, I mean, so certainly so the Google DeepMind model, as Brian mentioned, is one of their numerical. So basically, these models have been trained on historical data. And so one thing I do want to talk about when they talk about like academic research and these things that don't necessarily seem as exciting, one of the reasons why Google DeepMind is good is because it's been trained on really good historical data, because it's like the proverbial garbage in, garbage out. If we were to give it the original reanalysis products that we had, basically like the historical reconstructions of weather that we had, say in the mid 90s, Google DeepMind would probably be lousy, right? Like right, data we just didn't have that good idea of what the upper level winds look like and everything. But because of a lot of, tedious work that's been done by scientists to improve what we call data assimilation, better being able to take all the observations that we have, handle the uncertainties in those observations, and get us a really robust view of what the past looked like. If you give the model a really robust view of what the past looked like, then as it learns these statistical relationships, then it can give you really solid forecasts. And so kind of the way I think of it is, a dynamical model like the European Center model is basically what you do is you take your initial conditions and then you have these equations that govern the atmosphere and ocean and you run them forward in time. Whereas AI model is different because it's kind of like if you're in math class as a kid, you learn the equation and then you learn, basically like use that equation to solve the answer, to get the answer. Whereas an AI model is effectively like, here's a million answers, you learn the equation. So what they'll do is like, it'll statistically approximate a lot of these equations. And by doing that, it allows you to run these models a lot faster. So for example, when you're looking at like a hurricane season, we will take the European Center model forecast of water temperatures and then run an AI model, which is called ACE2, nothing to do with accumulated cyclone energy. It's the AI climate emulator version 2. What we'll do is run that for each ensemble member and see what it gives us. And we're just kind of running this like proof of concept. It works pretty well, given I only know it's forecasting high shear. And what we're looking at now with that model is trying to understand better when you have a hurricane season. When you start June 1st, you have a hurricane season, you have water temperature anomalies. But we know if, say, we were to run 2024 again, we get a very different outcome. Would we have the big lull middle of the season? Who knows? I would say probably not, but there's no way to know for sure, right? Because 2024 only happened that one time. But we know when you have water temperatures, that kind of loads the dice, but obviously weather is chaotic, atmosphere is chaotic. And so what we try to do with these AI models is better try to understand kind of the envelope of possibilities for a particular set of water temperatures. And one of the advantages that we have is like when you run a seasonal kind of run a hurricane season with, say, like the weather research and forecasting model, one of these simulations, you need a supercomputer, and it takes, may take you a day to run a season kind of thing. Whereas for the ACE2 model, we can run on our GPU, run one simulation in about 10 minutes. So just to tell you, it's just a lot faster. And not that these models are perfect, but one of the advantages that they have is that they're explaining variants that we're not explaining with these other approaches. And I think that is hugely important. And I think that's one of the reasons why you look at, say, for example, last year with Melissa, which is kind of like Google DeepMind's kind of like claim to fame, right? It did really help with that. And it's interesting, if you look at the track early on during its lifetime, the ECMWF ensemble, which is one of the best ones, was a little too far south and west. The Google DeepMind was a little too far north and east. If you look at the ensemble mean, you average a 2 and it was like spot on perfect. And basically that was what it did. It had a heck of a good forecast. And I think there's really just a lot of power in having independent information, because obviously all these numerical weather models, whether it be the European Center, the ones from the United States, the UK Met Office, like they all have very similar kind of physics packages, very similar kind of schemes. So you can run those models thousands upon thousands of times, and you're not necessarily getting that much independent information. Whereas because the AI model is kind of giving you answers from a different approach, it's giving you independent information, which can be extremely valuable at improving forecasting. So not that we're going to jettison everything else. I mean, obviously we need all these different approaches. And really one of the keys that we still need is really, really good observations, because these AI models still start from weather observations. Like, you need to give them really good data to start. And then if you give them really good inputs, then the forecast can show quite a bit of skill. So, as you said, the Google DeepMind, they just basically they published a paper and they released everything with their code as open source, which is really cool. So people can now go in and look at it and see what's going on under the hood. So hopefully leading to continued improvements in skill, both of that model and a lot of other AI models. That Google DeepMind is kind of, because they partner with the Hurricane Center, partner with fine folks like you, Brian. They've been working very closely, but there's other models that are also showing exciting levels of skill. And I think the speed, so being able to run a bunch of ensembles and giving independent information, to me, are two of the biggest kind of advantages of these AI approaches. Now, I'm certainly not an AI model developer. I haven't built any of my own neural networks or anything along those lines, but it certainly is an exciting time to be in the field. And as you showed at the top, right? I mean, we're looking at ensemble forecasts for 8, 9, 10 days out, 2 weeks out. Like, the fact that these models have skill at that lead time is pretty exciting. And I can tell you, when I started doing seasonal forecasting, which is back around 2000, when you put out a forecast in early August, you'd say, okay, here's the forecast. We know what we have up to early August, and that's what we got. Whereas now, when I put out a forecast August 5th, I have not a perfect idea, but a rough idea of at least kind of like what the shear is going to look like the rest of the month. And that's just really, really amazing. Like, we have these new tools are incredible, and it's really helping us, I think, to be able to kind of push some of the envelope in being able to forecast, just NHC being able to go out Genesis now 7 days, and even like the Climate Prediction Center goes out to weeks 2 and week 3, and they're showing some skill even at week 3. Like, it's pretty cool times in the field. I wish Bill Gray lived long enough to be able to see some of this stuff, because I think he'd be pretty excited.
Yeah. So Dr. Bill Gray was the guy that noticed in the late 70s, I guess it was, that the El Nino really affected hurricane season. He made that correlation, which started this whole process of seasonal forecast. And everybody that knew him remembers him vividly, because he was quite a personality. So why don't we check in with Jordan Overton at Fox Weather headquarters in New York and see what people are asking, Jordan.
Yeah, a lot of questions coming in about El Nino. We're expecting a lot of that. We're going to start off to one from Lisa on Facebook asking, during El Nino, can we get storms outside our high dates of early September or mid-October for Florida?
Well, I guess, Phil, see if you disagree with me, the El Nino will get stronger as we go through the hurricane season. So if anything, we would think the effect would be greater later on in the season. So the hurricane season might end early, but you can get those other kind of storms that form from fronts and whatnot, and that form in the Gulf or this off the southeast coast in the Bahamas, or maybe even in the Caribbean later in the year, but maybe in the extreme northwestern Caribbean is what I'm talking about. I don't know. I guess on average, you would have to say, though, fewer storms late in the year in an El Nino year, right, Phil?
Yeah, that's right. Because typically what kind of ends your hurricane season historically is the shear gets too strong, which is why usually when you have La Nina, these seasons tend to last longer. So I always point back to 2020, which 2020 hurricane season kind of got forgotten about because, of course, we had all the COVID stuff going on at the same time. But 2020 was just a crazy season and just kept going and going and going with all these powerful storms late. And so, when you have an El Nino, as we've already talked about, really increases your shear. And since shear is what tends to end your season, El Nino tends to historically end your season earlier. Now, as Brian mentioned, you can sometimes get these weird frontal things. I think honestly, storms like, I guess Arthur, to be fair, I guess officially formed from a tropical wave,
sort of
partially. Whereas more like a Bertha kind of storm, that's a classic El Nino, like, kind of not coming from a tropical wave, more like a frontal boundary kind of thing. So that's really something to watch. One thing we've looked at when you look at El Nino landfalls, number of landfalling storms does go down in El Nino, but it's really interesting when you look at where the storms that make U.S. landfall, where they form in El Nino versus La Nina. And if you look at El Nino years, basically what drops out are the storms forming in the deep tropics, so in the tropical Atlantic and in the Caribbean. As you go into the Gulf, those storms, the number of storms forming there doesn't really change that much. But typically if storms form in, say, the central or northern Gulf, they tend to be fairly weak just because they don't have that much time over water before they hit land. So, not that you can't get these storms, can't be big rainmakers, but in terms of like big catastrophic wind surge events, those tend to be fewer and farther between in El Nino years. And just to pitch some other work that we're doing, some research work, since the hurricane season looks to be a bit more on the anemic side this year, is we're actually looking at storms that have caused fatalities in the United States and looking at how those both just the overall number of fatalities as well as the storms causing fatalities, how those are modulated by various climate modes. And when you look at those, as you might expect, where you see fewer in El Nino years, but really what drops out are a lot of the storms that form in the main development region, which is basically the Caribbean and tropical Atlantic. And if you look at storms that have caused a lot of fatalities, about 3/4 of them do form in the tropical Atlantic and Caribbean, just because typically if storms form there, they've had a longer, kind of more time over warm ocean water. Typically storms tend to grow in size with time as well. So those tend to be your unfortunately, your higher loss of life storms. Not that you can't get those in the Gulf, but they typically tend to form a little farther afield. So this is some work that we're doing right now, and given the relative quietness of the hurricane season, hopefully something I can get written up here in the next couple of weeks.
Yeah. All right. Well, that we'll watch for that for sure. And that kind of adds to the work that you did talking about using the pressure really to determine how much damage is done, because you can have low pressure and a big storm, and big storms usually do a lot of damage, even if the winds aren't that high. All right, Jordan, what else you have?
Yeah, so we're going to kind of follow along with that question. I've got one from Dave here, I think is a great one. You've been talking about the Atlantic and the Pacific. What about the Gulf of Mexico, particularly Naples, Florida? What will be the effect of Super El Nino on Naples?
Well, so
I'll let Brian take that question.
Yeah, to add what Phil was saying, if you go back and look at the sort of strong systems in El Nino years, three come to my mind: Alicia in 1983, Betsy in 1965, and Danny in 1997. All pretty significant El Nino years. They all form kind of early. All like August storms, even though Betsy went on forever and went into September. But they all had effect in the Gulf eventually. So just because it's an El Nino, in fact, the El Nino doesn't affect the Gulf, I guess, as much as except maybe later in the year, as it would the rest of the Atlantic and the Caribbean, right, Phil?
That's right. If you look at kind of the circulation changes, like it really modulates the shear in the deep tropics. But if you look at higher latitudes, the shear modulation is fairly low. It's just, if you look at kind of the overall average shear, the average shear is just a lot higher as you move farther poleward in general. But yeah, I mean, that's why, storms, I think like Arthur and Bertha are really classic kind of El Nino storms. And if you look at 1997, we had quite a few storms early that were, you mentioned Danny, of several landfalls, but in general, fairly kind of weak anemic system. So again, hard to say what is going to be exactly on Naples and in the Gulf, but it's always something to watch. I always, definitely Gulf is always kind of a wild card. But in terms of getting like powerful storms out of the Caribbean this year, those odds seem very low, which is one of the reasons why we really historically I've talked a lot about the Caribbean, just because one, obviously it's a important area because obviously a lot of people live there and these storms can be extremely impactful there. And obviously you have to go back to Melissa last year to highlight that. But also that's just the area where our forecasts tend to have the highest levels of skill. The main reason being that the El Nino signal is so strong in the Caribbean. But as you mentioned earlier, lack of hurricanes in the Caribbean, lack of hurricanes is good news, I guess, in general. But you also do need robust tropical waves to bring rainfall to the Caribbean. If you usually in El Nino years, you go into significant drought. You see, they're already talking about like water rationing in Puerto Rico. Like these are big challenges. So,
yes.
We don't want strong hurricanes, but weaker storms that bring rainfall are useful. And it's interesting to see if you look back at some of the older tropical cyclone discussions in some of the monthly weather review articles back in the 50s and 60s, they will talk about this storm caused, this is way back in the day, so maybe it caused 10 million in damage, but overall it was actually beneficial because of the rain that it brought. So, obviously strong hurricanes in general, the net is very, very negative, but in terms of some of these weaker storms can actually be very helpful in terms of bringing rainfall, obviously, as long as the storm doesn't linger too long over any particular area. So, hurricanes in general, obviously, strong hurricanes aren't usually good, but the weaker storms can actually be very beneficial in terms of rainfall and hopefully ending droughts in certain areas. So
yeah, so that's true in South Florida as well. The water table in Miami-Dade County, for example, has been low, and Lake Okeechobee has been very low. And so the way the climate system works there is dependent on heavy rain in the summer. Now it's been raining more lately, so it'll be interesting to see what the next report is. All right, Jordan, you want to try one more?
Yeah, let's get some more here. So this next one, a little bit of a shift us to forecasting, a little bit about some educational question. The question is from Andrew. Is it possible for there not to be major hurricanes and still have Category 1 hurricanes?
Sure, right, Phil. In fact, 1997 was an example of that.
Yeah. I mean, and typically when we look at things like El Nino, the impact is going to be stronger on the stronger the storm, and that kind of makes sense, right? If you think about it, like, okay, for El Nino, it impacts the shear, and to get a major hurricane, you need to have a very large area of conducive conditions. To get a weaker hurricane, you need a small area with those conducive conditions, and so those tend to be more common in El Nino years. Like, so basically the longer the longer like the area you need to have of good conditions or favorable conditions for hurricanes, the less likely you're to see that in El Nino. So yes, typically in El Nino years, if you look at the modulation of, say, the number of storms or the number of Category 1 and 2 hurricanes, is going to be weaker than for the major hurricanes. So yes, certainly you can, this is a year where we very well may expect to see, maybe, we forecast overall 9 storms this year. It wouldn't shock me to see 11 or 12. We had 11 in 2015, another powerful El Nino with a whole lot of shear. But in terms of getting the strong storms, that just is what really tends to go down in El Ninos. I think really a good example of a year with a lot of storms, but not much in the way of hurricanes, was 2013, which was an oddball year to end all oddball years. And I'm sure, I know Brian and I talked about that year many times. It still is still in my nightmares, but my Red Sox didn't win the World Series that year, so it ended up okay from that perspective. But we had 14 storms, which is dead on the average, but we had only 2 of those became hurricanes. And we had nothing above a Category 1 all year. So you can have years with a lot of storms, just not much gets strong. And that's why in general, we have more skill with, say, predicting the number of hurricanes or the number of major hurricanes than just the overall number of storms. And Bill Gray used to always say, if you get one number right in a year, it's the number of hurricanes. That's the number you want to get on that. That's the number you want to get. And I think major hurricanes gets a little challenging because they're just the samples, the number of those each year is fairly small, whereas hurricanes, I think, overall is kind of a number where people generally know what a hurricane is, but also like it's something that tends to be a little more related to the climate modes than just, say, the number of storms, because you can get, you can get a year like 2004 that had 15 storms, but a ton of long track stuff, or 2005, which had 28 storms, but a lot formed closer to land. So when you look at that integrated ACE metric, those 2 seasons were almost identical, but one did it with just a whole lot fewer storms than the other. And 2020 is another crazy example. We had 30 storms that year, but the ACE was somewhat less. In 2004, we had to do it with 15. 2020, just everything formed very near land, got strong. And I still, whenever you look at the track map of 2020 and you look at the Caribbean and the Gulf, it still looks fake to me. Like, there's no way there were really that many storms tracking in that region, but we all know there were.
You get up every morning and there was another storm.
Exactly. Yes.
It's the craziest thing.
But if you look at the tropical weather outlook, then it was like cartoonish. And then they only were going out 5 days, let alone 7. But it was like 5 or 6 areas, like yellows and oranges and reds everywhere. And if it spun, it won that year. We almost got the hurricane pie for Christmas, for Thanksgiving, but not quite.
All right, Jordan, what do you have?
All right, so next question coming in. This one is from Jay Ricky on YouTube, and I've also got this a couple of times on TikTok as well. From you guys' perspective, being the experts, is there anything weird so far about this El Nino compared to in the past, other than the strength of the El Nino?
Well, I mean, my answer is not so much about the El Nino, but there is this super marine heat wave going on that the El Nino is sort of part of. Or I don't know, is it part of it, Phil, or is it just coincidentally, associated? Is the marine heat wave enhancing the El Nino? Do we know enough to make that case?
I mean, this is just a really, really like it's like just a classic El Nino, but just on steroids. Like just a really, really broad area of hot water.
Yeah.
And so I think, in terms of weird, I wouldn't say necessarily that it's weird per se. I mean, it's having very classic El Nino impacts, like the shear impact in the Atlantic, the tropical cyclones we're seeing in the Pacific. This is like textbook what you would expect to see.
Mhm.
You look at the long range forecast, the Atlantic looks like it's going to continue quiet. The Pacific, it's like not quite lit up like a Christmas tree, but all sorts of stuff that's probably going to form there. So this is very classic El Nino in that regard, but just in terms of its intensity, it's definitely really, really amped up in that way. So I wouldn't say necessarily that it's weird per se, but one thing I would say, and we'll probably kind of move into that as we go in the next few minutes, is this El Nino is extremely warm in the eastern and central Pacific. It's definitely a classic El Nino. Not we sometimes talk about these like central Pacific El Ninos,
Right.
Modoki El Nino, whatever you
Right.
want to call it.
Right.
This is definitely a classic El Nino where it's really hot in the eastern Pacific. As you get closer to the international date line and even a little farther to the west, it's already starting to actually get a little bit cooler than normal. So this one has already discharged a ton of heat, which likely indicates that by this time next year, the El Nino is going to have exited stage left or stage right a while ago. So we're probably going to be dealing with likely actually transitioning over to La Nina by this time next year. And another thing that happens with these El Ninos is typically in the Atlantic, we have what we call this atmospheric bridge mechanism, whereby the Atlantic right now, we don't hardly have any cloud. Like there's not much going. You look at the silent loop, it's pretty dry out there. And so because we don't have the clouds, you just get more sun hitting the ocean. And so the Atlantic, the last few weeks has already started to kind of, it obviously always warms up this time of year, but it's warmed up a bit faster than normal. Once you get into the winter of the El Nino, in addition to that kind of sinking motion, you tend to also get the trade winds, the winds blowing across the tropical Atlantic also tend to weaken. And once you start getting less evaporation off of the ocean surface, that tends to warm the Atlantic. So we may next year be dealing with one not having an El Nino. That seems extremely likely, probably in the 95 to 100% range for that, but also likely dealing with an Atlantic that's warmer than what we have now. So potentially, we could be flipping from basically what this year forecasting a pretty quiet season to next year forecasting a pretty active season. And if you look at landfalls in El Nino and then the year following, the number of hurricanes goes up by about a factor of 2.5. So not to say guaranteed, but I think in this case, we actually have somewhat of a forecast of opportunity, so to speak, where we can start to say this year, yes, probably very quiet, very confident in this, but next year, El Nino is not going to be here, and we'll probably have an Atlantic that's warmer than what we have now. So potentially could be a pretty robust season. And we talked a lot about that going out of 2023, which was a busy season, but we had the strong El Nino. So we said the Atlantic was record warm, and we think, okay, next year El Nino is gone, and the Atlantic is going to still be super hot. And that's what we got. And of course, it had some weird things, but of course, we still ended up being a very, very busy season just with no middle. But obviously, unfortunately, a very, very busy end. So, yeah.
Well, and I want to be sure that everybody heard what Phil said there. Just statistically, the year after an El Nino is 2.5 times as likely to have a landfall statistically, right? And I went back and looked in some detail at 1926. I've been, looking at that hurricane season, which was off the freaking chart hurricane season, right? We all know about the Great Miami Hurricane of 1926. But they had a July hurricane in South Florida as well. And 2 days before the night of the landfall, so the landfall of the Great Miami Hurricane was after midnight, technically on the 18th, but the night of the 17th into the 18th. On the 16th, there was a tropical storm that was affecting Miami. And then in October, there was like panic because a hurricane came over Havana. When you get a hurricane, if you live in a city and you get a hurricane named after the city, it's probably been pretty bad, right? So the Havana hurricane of 1926 was horrible in Havana. Like tremendous destruction, came right at Miami and just missed to the east. And that doesn't count the hurricane that went into Louisiana. And there was another one too, another strong hurricane. I don't remember where it went, but anyway, it was a crazy, insane year after the El Nino year of 1925. Now, I'm not saying we're going to get a Great Miami Hurricane next year, but Mother Nature has a way of compensating for a restful season, as Phil was saying.
Yeah, one last thing I'll point out on that is typically, especially when you get strong El Ninos, remember I said it's like this discharge recharge mechanism. We've discharged a lot of heat already, as you saw from the sea surface temperatures. It may take several more years. We may very well go into a multi-year La Nina event. And we saw that after the 97 event where we had 98, 99, 2000, really 2001 even, like kind of this long, prolonged La Nina event, in general, fairly busy season. So not to say that, we're going to see craziness next year, hopefully not another 1926, but certainly, likely to be a much more amped up season than what we're seeing this year.
Yeah, 2004 was actually technically an El Nino year, right? But just barely. It was and it got compensated for in other ways. All right, Jordan, what do you have there?
All right, yeah, so the next question, we've talked about this a little bit, but we haven't talked on it too much. I've gotten a couple of questions about Texas. Is there going to be more rain in Texas? Some locations are dealing with a lot of drought. What's the thinking for Texas in terms of their impacts this season?
Phil, you do the stats on this, but my sense is that Texas would have fewer tropical systems, but, hello, 1983, but that was a kind of form in the Gulf, make landfall in a couple of days kind of a thing, Hurricane Alicia. But statistically, Texas has fewer landfalls in El Nino years?
Yeah, that's correct. I mean, I think really, if you're worried about drought in Texas, this summer, maybe not a ton of relief, but normally in the winter of an El Nino year, you get a really, really amped up subtropical jet stream, which should, if it goes as kind of the normal way that these things go, we should start to see pretty significant rainfall across the southern tier of the U.S. So places like California, Texas, and Florida typically getting enhanced rainfall and hopefully ameliorating some of those drought conditions. So,
especially
one of the
North
things
Florida,
that we're seeing,
though, right? Though
what was that?
It's more North Florida.
Yeah.
And, in theory, more North Florida. But although you can get really severe storms in these years too that move south down the state. But I don't know. I don't know enough about the Texas stats to think whether it's mostly North Texas or whether South Texas participates in
it gets a little muddled. And obviously, the further away you get from kind of where the El Nino is centered,
right,
it's like, yes, this works, as Bill Gray would say, but then you get the exceptions that prove the rule. And for example, I was living in California during the winter of 2015 into 16. Everyone's like, oh, we have a strong El Nino, the drought's going away. And it didn't. It was a pretty dry year. Then the following year we had La Nina, and then the drought went away, and we had a crazy rain year. So it's one of those things where, like, yes, we have these nice things of this is how it normally works, but it doesn't always work that way. Now, typically, because this El Nino is so strong, it's probably going to have pretty kind of like typical impacts, and we certainly have seen that in the hurricane season. This has been a very classic El Nino-like pattern, with the Pacific being busy, the Atlantic being quiet. But how that teleconnects and how that responds during the winter kind of remains to be seen. As you mentioned, there's just a ton of heat in the Pacific Ocean, so exactly how that plays out kind of remains to be seen. But you would think in general more atmospheric rivers in places like California, probably better skiing in the Sierra, but we don't really know for sure. And unfortunately, where I live in Colorado, we're kind of sitting right on the dividing line. So some meteorologists are getting aggressive, saying it's going to be a crazy snowy winter, but probably it's safe to say we'll have more snow than we had this past winter when we had basically almost none. But will it be a monster snow year? Yeah, hard to say, as you move a little further north. So there's a little bit of uncertainty there, but I would say in general, Texas in El Nino years does tend to see more rainfall during the winter months. But it's there's a lot of other stuff going on as well. But in terms of getting relief this summer because of tropical systems, the odds are lower than what they would normally be.
Yeah, because normally systems turn north sooner in El Nino years by some measure. All right, Jordan?
All right, yeah, so next question I have coming in, let's talk about the East Coast a little bit. How's it looking for Johns Island, South Carolina?
Well, I mean, just overall, the chances of a landfall this year are lower, I guess we could say, right? For two reasons. One is there's fewer storms. Another is they do tend to turn north sooner. Is there any? So, what is your factor? Like, how much less likely is coastal South Carolina this year to have a landfall than normal, Phil?
Yeah, so I mean, what we do is we adjust we have landfall probability. So we don't forecast, South Carolina's gonna get a hurricane. We don't forecast that kind of stuff. What we do is you can calculate historical odds of landfall, which is based on just history. And then what we do is we adjust those forecasts we adjust those probabilities based on our latest forecast. And what we started to do is we forecast accumulated cyclone energy, so that geeky metric that we've talked about already. And what we do is we adjust it based on the ACE in the western half of the basin. And the reason why we do that is because we know that basin-wide activity goes down in El Nino, but in general, you also tend to see a lower percentage of that ACE in the western half of the basin for two reasons. One, as you already mentioned, storms are a little more likely to recurve in El Nino years, but also because you really knock down the Caribbean, that's all west of 60 by definition. So that really knocks down your ACE in the western half of the basin. So I just pulled up our South Carolina odds because I didn't have that memorized. So the way that we calculate probabilities is we calculate probabilities of storms tracking within 50 miles of each state. And the reason we do that is to kind of smooth out some of the noise of like yes or no. And you have a storm, for example, Hurricane Hazel in 1954. Was it a South Carolina or a North Carolina landfall?
Yeah, it was right on the border.
You zoom in and you zoom in and you zoom in, and it's still right smack on the border. So it's really hard to say, but when you have a 50-mile buffer, it kind of removes that kind of issue. And so historically, the odds of a hurricane tracking within 50 miles of the state of South Carolina is 29%. This year it's down at 10%. So not 0%. I mean, 10%, is still relatively high, but it's much reduced. And so again, mainly just because we are expecting a fairly quiet season. Is it possible to get something, maybe even a weak wave, it just kind of dinks around and then starts to get stronger as it moves into the subtropics? Sure. And you can sometimes get frontal stuff that develops off the coast and then drifts westward. So not to say that there won't be impacts, but overall, the odds are down this year just because we are expecting a fairly overall below normal season.
If I can just jump in real quick, Brian and Phil, I'm also getting, on top of that, I'm getting a lot of questions now about the Northeast and Long Island, Maine, New Jersey, Philadelphia, some concerns about, okay, does this mean with the Bermuda High and the recurve, is there a chance that stuff could slam into the East Coast, the Northeast, and New England? If you can talk about that a little bit.
Well, there's always a chance. So let's start there. But again, Phil calculates the odds of these things just based on statistics, and Phil, lower than normal odds, I guess would be the way to characterize it, right?
Yeah, I mean, it's interesting when you look at the Northeast, and that's where I grew up. I grew up in Massachusetts, so I've spent a lot of time looking at Northeast U.S. hurricanes. The relationship with El Nino and La Nina is fairly low. But it's hard, I think, too, because the sample size of storms up there is very low. So you don't have a lot of, it's not like Florida, right? You don't get hit by a lot of hurricanes up in, my neck of the woods up in Massachusetts or in the Northeast. Yeah, I mean, typically the Bermuda High, you tend to get more of these waves. The system's coming off Africa recurving. Really, to get a storm up into New England, you really need a big blocking high pressure area over the Atlantic provinces of Canada. That's what tends to kind of steer storms, basically prevents them from recurving and drives them westward. And kind of a crazy example of that would say be Superstorm Hurricane Sandy back in 2012, where you just had this massive high that just pushed the storm west. So yeah, I mean, again, the odds in any year for the Northeast are low. This year they're a little bit lower than normal, just given overall we just don't think we're going to see very much.
Looks like we might have lost Phil there.
All right, let's give Phil a chance to reconnect in case he had an internet issue. I mean, because what I was just going to ask Phil, talking about the Northeast, is what in the world was going on in the Northeast in 1954 and 55 when there were 6. Oh, there you are. Welcome back. Yeah.
Yeah, sorry, you blipped on me. I don't know what happened.
I don't know. You froze on us. So, in any case,
I apologize.
I was just going to ask. Being a Northeastern guy, I know this was before your time, but what was going on weather pattern wise in 1954 and 1955 when it seemed like every hurricane that thought about going up the East Coast went toward the Northeast and either went over or came close. I mean, with Carol and Diane and Edna and and Hazel was, in that, all going that same general direction. What was kind of locked in there and there was Barbara, I think in 53 kind of went that way. I mean, it was really kind of an amazing stretch.
Yeah, I mean, it's interesting because you will get times that like certain parts of the US are just more like under the gun, so to speak, for
Yeah.
whatever reason. Like
Right.
04 and 05, it was like crazy in Florida. And you have 2020, it was like Louisiana was getting hit by a hurricane every 2 weeks. In the mid 50s, you did tend to have more of this kind of high pressure over the Atlantic provinces kind of driving these storms. We had a lot of these kind of long tracked, kind of classic Cabo
Yeah.
Verde hurricanes basically come right off Africa and have these long tracks. And typically form if storms form, say, right off the coast of Africa, those are pretty likely to just recurve and go out to sea. As you get closer to the United States, as it say forms at like 40 to 50 west, that sometimes is a pretty good sweet spot for hitting the Northeast US. The further west storms form, that tends to increase the likelihood more for the Gulf, maybe for Florida, for the Caribbean, just because the earlier the storm forms and the earlier it gets strong, the more likely it is to start gaining latitude and start heading aground. And so we always talk about like the western periphery of the Bermuda High is kind of this magical thing where basically like where is that set up for that particular storm? Because if it's too far to the west, that's when you get landfall problems. If it's further to the east, the storms tend to recurve. And so it's interesting. You have some years where like a lot of storms take a very similar track, and then you have other years where it's like every storm just kind of does what it wants. And there's some years where it's like 2007, where we had a couple of big storms in the Caribbean early, and it looked like a big Caribbean year, and then we got a kind of a low pressure in the mid Atlantic, and it recurved everything out to sea the rest of the year. So hurricanes are pernicious beasts, and I see we're at the top of the hour, so maybe we can just end with hurricanes being pernicious beasts. But they are extremely challenging to forecast. And yeah, unfortunately, we can't say much. We can say a fair amount about how the season's going to play out in terms of overall conditions for the basin, but in terms of like what steers the storms, that's governed a lot more by day-to-day weather patterns, which we just really don't have the ability to be able to forecast, more than a few days in advance.
Yeah. Although maybe we'll be able to forecast 8 or 9 days in advance the way the new models are going. So, all right. Well, this has been fantastic, Phil, and always appreciate you coming on and talking to our viewers, and I know they appreciate it as well. So, all right, everybody. So that's Dr. Phil Klotzbach with us today, talking about his forecasts, and hopefully, cross our fingers that it's a quiet hurricane season in everywhere, not just in the numbers, but in what it means. But no guarantee of that. By the way, I just want to mention for those of you that Fox Weather is hosting this, and Jordan is at the Fox Weather headquarters. If you don't know how to get Fox Weather on your TV or your phone or your iPad, it's free no matter where you look. Just go to the URL foxweather.tv, and it'll be the instructions on how you get us on any device you have. So Phil, thanks so much, and we'll look forward to seeing you soon, and of course be watching for your sage wisdom if a hurricane develops this year. And of course, we'll be here covering it on Fox Weather. All right. Take care, everybody.